Hi, my name is Patrick, but you can call me 26, and today we're going to do another question, and this question is a classic. It's sort colors, right? So let's get to it. You're given an array of sums with n objects colored red, white, and blue. Sort them in place so that the objects of the same color are next to each other. Use integers 0, 1, 2 to represent the colors. Don't use the library sort function, right? Pretty straightforward. Let's get to it. So what we could do is, because of the background, we change white to green, right? So in this case, you're going to have the color green represents the color white because our numbers are in white, right? But otherwise, everything is the same, right? So we have this array of colors of the three colors, and we're supposed to sort them, right? So how we would do that is we would move all the 2s to the right, all the 1s leave in the middle, and all the 0s you're going to put to the left, right? To help us, you're going to have 3 arrows, right? So you have the 3 arrows. The white arrow is at the index that you're currently looking at. The red arrow is where the 0s are going to be, and the blue arrows is where the 2s are going to be, right? So let's get to it. So we look at the very first index, and in the very first index, we're going to have the number 2. And what we do is we swap it out with whatever is on the blue arrow, right? So we have 2 and 2 here. And if we swap them out, they're going to look exactly the same, right? So because there's a 2 on either end, if you swap them out, it's going to look exactly the same. So we do that, then we move our blue arrow down because we have already covered. There's a 2 already at the end. We can move our blue arrow down, right? And we proceed. We now have a 2 there and a 1, and we swap it out again, the 1 and the 2. And after we swap them out, we move the blue arrow down. And now when we encounter a 1, what we're going to do is we're going to ignore it and move the white arrow to the next index because the 1s are supposed to be in the middle. So we have a 1 there, so we move to the next one. So now we have a 0, and now we have a 0 and a 1. We swap it out in the opposite direction for what's on the red arrow, right? So we swap that out, and now we have a 0 and a 1 here, right? And we proceed like so. We have a 1 now. We can move first the red arrow up, and then after that, we move the white arrow to the next index because we're considering a 1. So let's go here. We now have a 2 here, and what we do with the 2 is that we swap it out with whatever is on the blue arrow. So we come here, look at that, swap it out, and now we have a 2. We can move our blue arrow down a level, and now we're looking at a 1 on our index, so we can proceed to the next index, right? And we have another 1, we can proceed to the next index. We have a 1, we can proceed to the next index, and now we have a 0, right? So what we do with the 0 is we swap it out with whatever is on the red arrow, like so. So we have a look at that. That's going to be the 1 and the 0. And in that case, we swap the 2 out. And now we have a 1 there. We can move our red arrow up. And now we're looking at a 1 in the 5th index. And what we do in such a situation is we move it up a level, right? We move our white arrow up a level. So we move it up there. And now we're looking at a 2. And we know that a 2 we need to swap out with the blue arrow. So what we do is we pick that, swap them out, move the blue index in, right? And now we're looking at a 0 on the 6th index. And now for the 0, what we do is we swap it out with the red arrow, and we move the red arrow up a level, and now the white arrow and the blue arrow are together, so that means we can terminate our loop. So we have successfully sorted our array. You see the reds are at one end, the 1s are in the middle, and the 2s are at the other end. So this is how we sort it without using the sort function. So let's put all that we have done into code. Now the first thing we want to do is we want to create our various arrows. So let's create the red arrow, the blue arrow, and keep track of our index, right? So we say var, this is going to be red is going to be at the beginning, so we say 0, like so. Then we're going to have blue is going to be at the other end, so we say this is going to be nums.count minus 1, like so. Then we say I is going to be 0, like so, right? So we have all that, and we say while I is less than or equal to blue, like so. What we want to do is come here and we say if nums I is 0, like so. If nums I is going to be 0, and we need to give this equal space, right? If we're looking at a 0, what do? Well, we need to call a function that doesn't exist yet. So this function is going to be called swap, And what swap is going to do is it's going to take in nums And this is, of course, since we're going to be modifying it, it's going to be in out, and we come here, it's going to be filled with integers like so, and it's also going to take in, let's say, p, which is going to be an int, and then it's going to also take q, which is going to be an int, right? So we get that, and what it's going to do is it's just going to take in our array, and we could use a tuple to swap out in Swift. We could come here and we say nums, and we're just going to have p, comma, then we say nums q, and we're going to set this equal to tuple. It's going to be nums q, like so, and then nums p, like so, right? So we do that, and they are going to swap out, right? Now, in this case, you could put it to use. We could come here and we say, if we come across a 0, what we want to do is we want to call the swap functionality. Swap, and the nums is going to be the nums. And to use it, of course, you need to put an ampersand because it's an in-out parameter. So we say nums, the p in question is going to be the I. What's at the I index? And what do we swap it out at? We swap it out with what is on the red, right? So for that, we just come here and we say red, like so. So that's going to swap it out. And then we increment our red plus 1, right? So we come here and we say red plus equals 1, right? So we move it up by 1, and then we come here and we say I plus equals 1, right? So that's going to be that. And we come here and we say else if nums I is going to be 1. If we come across our 1, all you need to do is move our pointer, our index up by 1, because we're going to leave them in the middle, right? So else, that means that there are only 3 options. Else, if you come across a 2, what you do is you just call the swap. Call the swap, pass in the nums like so. The p is going to be I, and what we're going to swap it out with is going to be on the blue arrow. So we say here blue, and we move the blue arrow down by 1. So we say blue minus equals 1, right? So we move the blue down by 1. So if we do this, this should work exactly as our example. Let's run our code and see if it works. So we run it with the test cases, and this works. And if we submit it, this presumably will also work, right? So that is sorted, and we can now proceed to talking about the time and space complexity. So the time complexity here is pretty straightforward. It's just O of n, right? Because we loop through the array from beginning to the end, and we swap elements around in the array, right? So for that reason, the time complexity is O of n, and we don't create any extra structures because we sort the array in place. So the space complexity in this case is going to be O of 1.